Hello everyone. Today the humble math tutor brings you an application of differential equations, inflow and outflow of fluid from a tank. In this problem, a 100-liter tank is full of water, polluted at 20 grams per liter. So at this volume, there would be in total 2,000 grams, that's 20 times 100, 2,000 grams of pollutant in that tank. Water at 5 grams pollution per liter begins pumping in at 4 liters per minute, mixing thoroughly with the existing water. At the same time, water exits the tank at 4 liters per minute. A graphic illustrating what's happening in this question is here. So we have, this is the concentration of pollution, 5 grams per liter. And this is the rate the water is flowing into the tank. And this is the rate the water is flowing out of the tank. The problem requires us to determine an equation relates the total quantity of pollution in the tank Q versus time T in minutes. Let's see how we would do this problem. The best way is to set up this template, which works for all these tank problems. dq by dt is the rate of change of pollutant, Q. Remember, Q represents all the pollution in the tank, the total number of grams in the 100-liter tank. This is the rate at which it changes. Now, what we set up is the concentration of the inflow times the rate of the inflow minus the concentration of the outflow times the rate of the outflow. If we can set up these four quantities, we have our differential equation. So let's get started. The concentration of the inflow was given to us as 5 grams per liter. And I'm going to put the units in now. It will be instructive in a minute. And the rate of inflow is 4 liters per minute. The concentration of outflow is, well, to get that, it's a bit of an operation. You'd have to take the total quantity of pollution in the tank and divide by the 100 liters. So there's Q grams of pollutant in the tank divided by 100 liters. If you divide those, you're going to get the concentration of pollutant. You're going to get the number of grams of pollution in a given liter, in 1 liter, grams per liter, if you divide the total quantity of pollution in the tank by the full volume of the tank. And we'll multiply that by the rate of outflow, which is also 4 liters per minute. Okay, now the reason we have the units in this line is you're going to see that they're helpful. They cancel out. Because if you have 5 grams in a given liter of water, 5 grams of pollution in a given liter of water, but it's flowing in at 4 liters per minute, you just multiply those and you get the number of grams per minute going into the tank. In other words, it's like the L's cancel, the liter symbols cancel. And you get 5 times 4 is 20 grams of pollution going into the tank per minute. And over here, same thing, these L's cancel, and you're going to get grams per minute exiting the tank. So once they cancel, you have 4 divided by 100 is going to be 0.04 Q grams per minute. Writing it without the units, we have our differential equation ready to solve. It will be 20 minus 0.04 Q. The next thing I recommend you do is factor minus 0.04 from these terms. We want the coefficient of Q to be 1 for simplification reasons later. It makes it an easier equation to solve. So I think you should go like this next, 0.04 times Q, and then find a number which when multiplied by minus 0.04 gives you 20, and that would be 500. So that's dq by dt. At this point, most professors want you to be formal about it. It is possible to skip to the answer, but most professors want you to take a moment and say this. Let z take on the role of q minus 500. In that case, dz by dt is the same as dq by dt. and we get a slightly simpler differential equation then. So the next line would be dz by dt equals minus 0.04 z, which has the template solution that z equals ce to the minus 0.04 t. But wait, z was q minus 500, so we continue like this. Put the q minus 500 in where z was, e to the minus 0.04 t. Very good. And then bring the 500 to the right side, and we know that q is 500 plus ce to the minus 0.04 t. But what is c? c is a real number. We need to find out what that number is. To get that, we need some kind of condition, some kind of point on the curve already known. And if you go back to the problem and read what it says here, at the very start, at the very beginning, before the water flow started, there were 2,000 grams of pollution in the tank. So that will be our initial condition. So that says Q at time 0 is 2,000. We're going to sub 0 in for T and 2,000 in for Q in this equation, and we will solve for C. So we get 2,000 equals 500 plus CE to the minus 0.04 times 0. Bring the 500 to the left side, and we get 1,500 equals CE to the 0. Anything to the 0 is 1, so we get that 1,500 is the value of C. Place that now known C value in here, and you're finished. We have the differential equation that's required. So therefore, Q equals 500 plus 1,500 e to the minus 0.04 t. And that's the required equation relating time to quantity of pollution in the tank. If you enjoyed this video, please like, subscribe, and share. And if you have suggestions for topics for future videos, please leave them in the comments section below. Thank you.